So I have a review talking about this book. So I think making it better, I'm going to create a book that we talk about Abacus math. Hey Audrey, good morning. Good morning everybody. Hello, hello, hello. Talking about Abacus. We are talking about Abacus. What is this strange thing? This strange thing is about counting and doing adding on the Abacus. But first what we're going to do is we're going to learn how to read the Abacus. When we read it, we have all the bottom beads. All the bottom beads, these are the beam, this is the beam, this is the bottom bead, right? The bottom beads have a value of 1. 1, 2, 3, 4. So I know this is 4. This is 4, that's 4, this is 4, this is 4. So after 4 is 5. What's 5? This is 5. This will always be 5, no matter what. This is 5, this is 5, this is 5, this is 5. But the difference is the place value. So if you notice, I actually started the 0, I actually started my 1 where the dot is. You can have a dot here and you could start here, it just depends on how big your number is. So the Abacus actually keeps track of your numbers. So if you notice, I started here and I could do 1, 2, 3, 4, and then 5. So this will always have a value of 5. So then when we add, we have 6. How do I know? 5, 6. Anything in the bottom, so we have 5, and this is a value of 1. So we also decompose. Decomposing is 5 and 1, and then decomposing 5 and 2, and then decomposing 5 and 3. So when we count it, 5, 6, 7, 8. 5, 6, 7, 8. 5, 6, 7, 8, 9. So this is the abacus, and we are learning how to count and understand what the beads are talking about. So when we do 10, how do I know what 10 is? Well, if you look, 10 is just a 1 and a 0. Let me see. So this is 9, right? That's 9. So this is 9. Whoa. This is 9. How do I know that this is 9? This is 9 because it's 5, 6, 7, 8, 9. So now, what do we do for 10? Well, what does 10 look like? What does 10 look like? 10 looks like, oh, where is it? 10. I'm trying to find my little, that's 13, that's 12. Oh, I should just write it. I'm just going to write it. Okay. So 10 is a 1 and a 0, right? We all know what 10 looks like. But on the abacus, 10 is that. That's what 10 looks like. Oh, brilliant. I will do this. There we go. Much better. So, when we do 10, we have 1 and 0. How do I know? Because if you look, there's a 1 and there's a 0. So Abacus also does place value. Abacus also does place value. I'm trying to rearrange. Oh no. Okay. So we have when we're still counting, right? So we have 10 and a 0. Well, it's easy. We have 10 and 0, and then we have 11. So this is 11, and then this is 12. So that's 12. 1 and 2. 1, 2. So then 2. If we do this is 22. So that's 22. So if you notice, when I said 4, so this is 4. So then what's that? That's 40. How do I know? Because it's a 4 and a 0. This is the place value that tells me this is the ones. So when we do 4 and a 0, this is 40. But if we do that, this is 400. Notice that there's the place value. When we do place values, right, just like when we're writing, these are all the ones, these are all the tens, these are all the hundreds. Same thing with this. These are the tens, this is the ones, this is the tens, this is the hundreds. So what is that? What would that be? Anybody have a guess? Anybody have a guess? Open to comments. Let's see. Oh, I love this. Ooh. Hi everybody. Welcome, welcome, welcome. So yes, 400, 1, 2, 3, 4. So it'd be 4000, 4000, right? So it's kind of nice that we have these dots to help us to keep track, right? If I started here, this would be 4. But what happens after that? Then there would be a place value right here. There's a decimal. There's an imaginary decimal. And then this would be the tenths. So it would be 0.40, 0.4. So this would be 0.4, and then this would be 0.04. So we can also do decimals on the abacus. I don't know if anybody talks about decimals, but that would be the decimals. And then we go the other way, right? So understanding all about place values on the abacus. So good. We have 4,000 here, and then this would be 40 40,000, right? And then when we continue to count, we do 5. So it'd be 5, right? 50, 500, 5,000, and then 50,000. This one, so going back, we could start here. We have this are ones. You could start here, but then your dots will be a little bit off. But the reason why this is here, so then we have decimals. We can do like adding money, right? Our money system is in the tens, so we do $3.25. That's what $3.25 looks like. So $5, $8. How do I know it's eight? 5, 6, 7, 8. This is a value of 5 for those that just came in. This is the value of 5. So 5, 6, 7, 8, and then be 2, 5. 0.25. How do I know? Well, because I named this as my ones column, this is my ones column, then anything after the ones in regular math will be my decimal place. So this would be 25 or 0.25. 8.25. So, anybody have questions? Wow. Welcome to learning and how to count using the abacus. Yes, we're all counting on the abacus, and we're trying to read what the abacus looks like. I'm going to just say hi to everybody. There's a lot of people. Wow, I'm surprised with all the people that are coming on board. But we're talking about counting on the abacus. So, why are we counting on the abacus? Because we can do adding, subtracting, multiplication, division. But what I'm going to do now is I'm going to do simple adding. What is simple adding? Simple adding is when we do the 3 plus 5, right? So if it's 3 plus 5, well, we just add the 5. This will always be the 5, right? So we add 3 and then we add 5. And so my answer is 8. So I noticed in regular math, we only do 2 add-ins. But in Abacus, we actually do like more add-ins. We do like 4 to 10 add-ins because there's like Abacus competitions. But anyways, so when we count, we do 2 plus 2. I'm sorry, when we add, it's 2 plus 2. How do I know? Because I'm moving these 2 beads. When I move 2 beads, I know I'm just moving the 2 beads and I'm just adding it to make it 4. So this is really simple abacus. So when we go through the book, so we've gone through like trying to understand what the numbers are, right? And that's what this beginning abacus is. My beginning abacus book talks about the numbers from 0 to 1, and we just do a lot of bead recognition. So when we do bead recognition, we're just doing a number to the bead. So when we do 7, knowing what 7 looks like, right? 7 is a 5, 6, 7. Some of the kids count. This is also introducing counting on because we could start from here. 5, 6, 7. Counting on is the process of counting not from 1, right? So it's kind of cool because when the kids can see and understand what the numbers are, they can count from anywhere that's on the abacus and they don't have to rely on the actual symbol because the symbol itself is very abstract, right? If you have any questions, let me know. Oh, hey, there's a lot of. Oh yeah, my son does abacus, and he's in 7th level. That's fantastic. Yeah, I have 3 boys, and they've all finished the abacus curriculum. But I'm trying to make abacus more fun. So I have these activities that I've created, and trying to make it like more fun for the kids to learn abacus. And I have like a whole workbook that I've been working on. Then they go into like more future math, not future math, but more complex math, and this one is like solve the hidden word. And so, um, so this book is actually quite interesting. I actually just made this book, and it's available on Amazon. And so that's what it looks like. But then what it's cool, because I actually have instructions on how to do the adding and how to do the 10 frame. So this is the next level and more complex than what I just showed you with the counting. So when we count, we're doing bead recognition and understanding how to do the adding and subtracting, right? Just simple. Then we actually start doing the actual um, formulas. We call it in Abacus. In Abacus, we call it formulas, but in regular school, we just call it 10 frame. So the 10 frame, we need to know that 4 and 6 is 10. This is one of those fundamental things that we need to know. So that 4 and 6 is 10. That what else is there? There's that 8 and 2. Okay, 8 and 2 is 10. But how do we use it on the abacus? Well, to use it on the abacus, we're actually going to utilize this 10 column. This 10 column is going to be our magical column. And in this book, I call it the asteroids. So we go to the asteroids to get more, to get more. But what we do is we actually change the formula, we change the equation, and this is the beginning parts of algebra. So, right, algebra kind of manipulates and moves stuff over. So if we take this 2 and move it to the other side of the equation, that's what this is, right? This is the instructions of moving the plus 2 over. So when we move it over, we actually reword it and we get this equation right here. It's plus 8. If I want to add the 8, it's another way to plus the 10 and take away the 2. So if I have a question, so instead of learning doubles, right? Instead of learning doubles, like 8 plus 8 is 16. Okay, I want to add 8. If I want to add an 8 on the abacus, what I can do is I can add a 10 and then take away the 2. So when the kids go through this, they will see that there's a number pattern. The number pattern is if I want to add 8, I have to take away 2. This is the 2 I'm going to take away, and then I add this 10. So this is where we do, I guess we call it regrouping in math, right? We have regrouping in math. Yeah, yeah, this would be regrouping, right? So, so instead of like trying to figure out how to make a 10, because we can make a 10, but if you know the fundamental foundations of how to make an 8, right? It's 10 minus 2, then there you go. So all we have to do is, so even if the question is 9 plus 8, we take away the 2 and plus the 10. And that's a common thing. That's a common rhythm that we learn in Abacus. So even if we had 7, right? 7 plus 8, it's plus the 10 minus the 2. And so I have this book that just talks about all of the things. So I have this whole book, and we talk about like spinning the wheel, and I've actually gone through it, and I've done through all of the questions to make sure that it makes sense. I have a color by number. So usually um, these are activities for for kids that hopefully they will find it interesting. I have a student that really enjoyed this, and so one of them was a oh. So then this is a puzzle. So here's the puzzle board, and these are the puzzle pieces that they have to like answer the questions to make the puzzle. So one of them is to like use scissors to cut. So part of the cutting skills, and then matching, making sure that it makes sense, right? So that was adding that, and then I have like the hidden word. Wow, that's a lot of people. I've never had so many people before. Welcome. Good morning, everybody. Hi. Tap, share, like. Oh, thank you so much. Tap, share the live, and follow. It really sucks having old eyes because now I gotta sit back and I can't see. Oh, thank you so much. Thank you so much for encouraging for others to view. I'm really surprised like how many people are here. Um, so this is my book that is available on Amazon. I was going to make it. I have to figure out how to make it on TikTok, but I'm not sure. But then I do have this one, which would be the beginning of everything. Um, so if we were going to continue on, I can still talk about a lot about abacus. And so this is my other book. This is my preschool book. The reason why I call it preschool is because this is introducing how to read the abacus and understanding the relationship of the numbers. So I have it like where we count forwards and we count backwards. So this is counting forwards, and then this one's counting backwards, and then and I broke these up into lessons, right? So this one was what number comes in between. So if I give you like this number, which is 1, and then this number is 3, then I have it where, okay, what's in between? So they can either, when they use the abacus, they can either add the 1 bead, because that's what we're doing, or we can go to here, which is 3 beads, and we can take away the 1 bead. So this is the introduction of adding and subtracting. And I heard that, taking away was a difficult concept for a lot of the kids. But in Abacus, it's, because they could see it, on the Abacus, it's easy for them to see that I'm taking it away, right? So when we do 4 and we take away 1, we have 3. If we have 3 and we take away 1, see, the idea here is knowing how to move the 1 bead. We're not talking about when we count. We do 1, 2, 1, 2, 3, 1, 2, 3. We start from here to start with 1. But when we take away, right, we're understanding we're taking away the 1 bead, which is really interesting, because then they understand that we're only taking away this 1 bead, not that this is a designated number 1. So if I have 4 and I want to take away 1, we're not taking away from up here. We're going to take away from here, because we're talking about 1 and the 1 bead. This was one of the concepts I remember that the kids were, it was a little bit of a blip, because I guess in regular math, we label it and then we think that this is it. No, in Abacus, we label it just to understand where we are, but we have to understand that this is the 1 bead that we're talking about. This is the 1 bead. So when we do the when we do the question, the way I have the questions broken up is we do it systematically. We show 2. So this one is 2. So if I have 0 plus 2, I'm taking 2 of these beads, right? So if I start here, right, if I have here, this is 5. And then I only need to add 2 beads. So these are the 2 beads. If I have 6, right, ooh, that's not good. If I have 6, right? And I want to add 2 beads. These are the 2 beads I will add. The idea is only to add the bead number, the items. So this is a 1-to-1 correspondence, right? Because we're adding 2, and that would be 2. So this is 8, right? So then if we do 7, and then we do 8, I'm sorry, 2, we add 2, and there we go. So, but now it gets more complicated, because now we're going to start using formulas. So let's say we did 4 plus 2. This book doesn't talk about 4 plus 2. Why doesn't it talk about? Because we're going into the 5 frame, and that's what the 5 frame is. Wow. Oh, okay. So the 5 frame. So what does the 5 frame mean? Okay. 5 frame, if anybody has questions, let me know. The 5 frame, remember, now we're teaching in school this 5 frame, which is fantastic, because it really works in line with Abacus. Oh my God, it's so fantastic. So this is my book that we're going to be doing, and we're going to just walk through a little bit of what the 5 frame is. So what is the 5 frame? Well, we need to remember that 1 plus 4, 4 plus 1 is equal to 5, right? The other way to do it is 1 plus 4 is equal to 5. This is fantastic. This is great. Now, in Abacus, we actually take it one step further. How does that make it? Well, what we're going to do is, let's say we're looking for the 4. What we do is we take this 1 and we put it onto this side. So to make a 4, we can plus 5 minus 1. The reason why I want to say plus 5 is because I want to know I'm adding the 5 on the Abacus. So if the question is 4 plus 4, and you could learn your doubles, right? Okay, doubles is 4 plus 4 is equal to 8. Fantastic. Now, that's great. In Abacus, we don't learn doubles. We actually learn the fundamentals of it. So what is it? If 4 plus 4, this is the 4 we're looking for. If we look, do we have enough beats? So it's also critically thinking, do we have enough beats? No, we don't. No, we don't have enough beats to add the 8. So what to add the 4. So what do? What we could do is we can utilize this 5. We can utilize the 5 and take away the 1. And my answer is 8. Okay. So let's take it one step further. let's do 3 plus 4. 3 plus 4. 3 plus 4. Well, in regular math, right? In American math, I don't know where everybody is in the world, but in regular math, right? In American math, there are some strategies to say, okay, you learned your 4 plus 4 is 8. That's your doubles, right? Learning your doubles. And then you take away 1 because it's a 3. Okay? You could learn that, or you can go back to the abacus and just say, well, I have 3. Do I have enough? No. What's another way to add 4? Well, I can plus the 5 minus the 1, right? It's the fundamentals of abacus. It's just learning the basics. This is basic math. This is basic abacus math, right? We don't need to do the double strategy. So let's take it one step further. Let's do 2 plus 4. These are simple, right? The examples are simple, but it's a fundamental concept. So let's say we have this. You could learn, right? 2 plus 2 plus 2. Okay, we could do that. We can learn our doubles and then add 2. That's not a problem. We can learn our doubles, right? And then take away 2. That's great. This is great number sense. That's fantastic. Or we can go back, and if I add the 2 and I ask myself, is there enough to add 4? No. So what do? Anybody know? Can anybody following me? Anybody following? So if I want to add 4, anybody have the question or the how to do this? You can type it in the comments. So all I got to do is I have to add the 5 and take away the 1 because this is another way. This is the building block of adding. And my answer is 6. So I didn't have to memorize my doubles and do strategies and be all crazy. I just have to memorize and remember that if I wanted to add the 4, I can add the 5 and take away the 1. So this is the fundamental concept that we're doing in Abacus. And then it's great because in school they're teaching us how to do the 5 frame. That's fantastic. I love that they teach you to do the 5 frame. But that's as far as it goes. The only thing that we teach the kids in school is how to do 1 plus 4 and 4 plus 1. That's all they're doing. They don't go and doing into the next step. The next step here, right? Okay, we did 4. What's the next step here? Well, if I want to look for 1, 1 plus 5, take away 4. Brilliant, right? Like, it's so amazing how simple it is. It's so simple, but we don't take it to the next step. But once they learn how to do this, oh my God, it is fantastic. It is fantastic, right? Because it's using the same numbers. We're introducing a little bit of algebra, right? This is a little bit of algebra, right? Is this a little bit of algebra? What grade is this for? This can start, so this can start in, I would say, preschool. I would try to start in preschool. That's why I created a preschool abacus math. And we do is learning how to read the abacus. So we learn how to read the abacus. Some of the kids start in kindergarten, right? When we can start doing the adding and subtracting, because then they actually understand the concept of adding and subtracting on adding and subtracting. And then they can move forward to first grade, right? And my kids actually, when they go through the abacus, we go through and after they know how to do the tens, after they know how to do the tens, we start learning how to do like addition, multiplication. So 2 plus 2 plus 2 plus 2 because um, it's a bunch of equations that gets them to understand. Back to the question, what grade is it for? You can start it in preschool, you can start it in kindergarten, or you can start it in first grade. You can start it in second grade, but the kids would be like, I've already learned this. What's the point? So there's a little bit of a mental thing. If they're open to it, it'd be fantastic. I've had students that actually started this when they were like 8, 9, and 10, and they were patient enough to go through the quote unquote really simple, easy stuff, but the questions do get harder, right? So, like this one here, they actually start getting more difficult, but instead of doing like 9 plus 9 is, my doubles, and then I have to add another 5. So there's a whole like methodology for the abacus when we do this. So my recommendation, like the sweet spot, is preschool, kindergarten, first grade, second grade. You could do third grade, but I think that's a little pushing it just because the kids are like, why am I learning how to count on the abacus? So I think there'll be a little of a mental block. But if they're open to it, oh my God, this is the greatest thing next to sliced bread. Because um I mean, when I learned it, I actually learned it as an adult and I started teaching it. And so, teaching abacus and going through the process, I can't believe how easy everything makes it. So, thank you for your question. Um, I hope that helped. Let me know if you have any other questions. Um, let's see. I'm just checking to see if we have any more questions. Um, you know someone who's taking algebra, this would be the reason why to invest. Oh yeah, right? So going back, this would be going back to my thing. So this is the introduction to, I would say it's introduction to algebra. Algebra. Because we're talking about like moving the equations and finding the x, right? So if we have x is equal to 5 minus 1, I should learn more algebra to bring it together. I don't know my algebra. I only know like abacus. And I'm trying to grab like how abacus relates to regular school, because it does. It's like crazy on like how common it is, how easy it is. So thank you so much, Audrey, for letting everybody know that my books are available on Amazon. So, whew, okay, we have 6 people. And anybody have questions on what I just talked about? So I can go back and just start talking about like how the numbers are. But that was the one thing, is understanding what the 5 frame is. When they understand the 5 frame, we actually build on it, and instead of going into working memory, this goes into memory. This actually goes into long-term memory, and that's what we're trying to do. We're trying to put all this information, not all, actually, if you really think about it, long-term memory. If I really think about it, we're only putting in these 2 concepts into long-term memory. We understand how to use it, so that's why we have these questions. But then when they start going into this, will actually be into their long-term memory. So obviously, when we start doing, like, say, 30, 34, right? Let me do that again. So even if we have our questions, right? We have 34 plus 4. Well, again, we could learn our doubles, or we can add it. We can even do 14, right? So we add 4. Ha! This is a good one. So we remember that 4. Okay, what are we doing? We are adding this 4. When we break it up in Abacus, right, we do 34. So this is 30, this is 4. How do I know? Well, this is my 1s, this is my 10s. Not a problem, right? Easy. Now we're adding. I'm going to put a plus sign. Now we're adding. We do 4. Well, great. We add 4. We add 1, right? That's the 1 here. And then we add 4. Well, what do we remember? What do we remember? We remember our 5 frame, right? 1, 2, 3, 4, 5. 4 plus 1 is equal to 5. We remember this. Remember, when we want to do plus 4, is there enough to plus the 4? The question is there enough to add the 4? No, there's not enough to add the 4. So what do? We can use the 5. We can manipulate the 5. We can look at this 5 and add it and make it more versatile than just adding the 5. We can add the 5, but we need to take away the 1. So we have to add the 5 and we take away the 1. So that is how we get 48. So instead of learning our doubles, what we're doing is we're utilizing this 4. We're utilizing the 4 to make it more versatile. So we don't have to make a 10. So here, what would they say? They would say, oh, well, the other concept in school that they're doing is, well, how do you make a 10? Well, I can add 6 to make 40, right? And then I have to take away 6, so then I have to take it away from here, and this would be 8. So then my answer would be 48. I think that's it. I think that's how you make a 10. But In Abacus, I don't teach how to make a 10 this way. I teach you how to make a 10, how to make a 5. So in Abacus, we do 1 plus 4 is equal to 5, or 4 plus 1 is equal to 5. And then we manipulate around. Now it's the same thing with the 10 frame. The 10 frame is the same thing, but it's different because now let's take the 4 as an example. I don't know if I did 4. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So there's 6, right? 4 plus 6 is equal to 10. Now, this is, this is what's like amazing about it, right? We know that 4 and 10 is equal to, 4 plus 6 is equal to 10. We take this, right? We take this and we move it over here. So what happens? We can say 4 is equal to 10 minus 6. 10 minus 6. Why are we going to use this? Because in Abacus we actually have a system. There's set protocols. So let's do 4. You know what? We're going to do multiplication. 4 plus 4 plus 4. So in Abacus it's common to have 4 add-ins, right? So we have 4. So I add my 4. We have 4 here. Do I have enough beads to add the 4? Oh, maybe I should move it up a little bit. Do I have enough beads to add the 4? So that's the question, right? That is the fundamental question. The fundamental question is, do we have enough to add the 4? Because I am right here. So if I want to add 4, let's see. If I want to add 4, is there enough to add the 4? Oh, I don't want to maybe do that. No, there's not enough to add the 4. Well, what's the other question? The other question is, can I add the 5? That's not a good marker. Let me do this one. 5. Can I add a 5? Yes, I can utilize this 5. So what is this? This is 4 is equal to plus 5 minus 1. So I plus the 4 minus the 1. Okay, so my answer is 8. So I want to add another 4. Well, this is where it comes into the process of elimination. That's another thing that the kids will learn is the process of elimination. Because now we go into, can I add a 4? No, there's not enough beads to add the 4. Can I add a 5? No, I cannot add a 5. Can I add a 10? Yes, I can add a 10. So what do I do here? Well, if I want to add a 10, I have to utilize this equation, the 10 frame equation. What is the 10 frame equation? Well, I can use my 10. So 4 is equal to plus 10 minus 6. So I go plus the 10, and then I take away the 6. And my answer is 12. Right? So in Abacus, we talk about the process of elimination. There's a lot of pinks. I have a lot of pink. Anyway, maybe I do another color. Green. Another green. Oh, let's do this one. Okay, so we're continuing on, right? Now our next question here is, can I add a 4? Is there enough to add 4? No, there's only 2 beads here to add a 4. So my next question is, can I add a 5? Yes, I can add this 5. So what happens? I go back and I add 4 is equal to plus 5 minus 1. So plus the 5 minus the 1. And my answer is 16. Yeah, that's it. All right. Oh, that was it. I mean, that's a lot about Abacus, but there's a lot of like huge concepts. But I break it down into bite size so the kids can start learning how to do this. So when they actually start learning, how to add simple. We call it simple because there's no equations involved. But then once we start doing equations, these are what they have to remember. But once they remember this, once they understand that this is put into working memory, then they can add and subtract anywhere they want. I've only been doing adding, right? It's a little harder to do subtraction questions because I don't do subtraction questions very often. So I'd have to really think about it. If I did 16, I don't want to use this. I'm gonna dump this. All right. Let's see. That's not a good question. Let's look. 16? Is that a good one? No, that's not a good one. I'm trying to find a marker. That's what I'm trying to find. Okay. Okay, after this I'm gonna go because I gotta go get ready for class. I have a student and we're talking about the 10 frame. So 16. So we could do 16 take away 4, right? We have to do 16 take away 4. Well, I need to take away 4. Can I take away 4? Is there enough b's to take away 4? No. There's not enough b's to take away 4. So what do? I have to take away the 5, add the 1. See how it's the reverse? So if I want to minus the 4, I have to take away the 5 plus the 1. That's what this is. So we're still learning our 5 frame, but now we're really manipulating it. So we have the add the 4 is equal to plus the 5 minus 1, or I have to take away the 4 is equal to minus the 5 plus the 1. So it's really quite interesting on how like Abacus actually does build on this fundamental equation, fundamental concept. So that's why the 5 frame is so amazing. Like in regular school, we talk about it, but we don't manipulate it so it works to how we need it. So, all right. Wow, there's 7 people. That's crazy. But yeah, I mean that's one of the things, right? One of the things is to be able to utilize and how everything works together. So working with Abacus, it's really fundamental. It's really fundamental, and will bring solid, number sense. That's what it is. And so this will build. I mean, we're not doing algebra, but it's the beginning. It's the introduction to algebra, and other complex math that I don't know. I mean, we do distributive property. That's a multiplication term, right? Distributive property. Funny thing is, distributive property is very common in algebra, not algebra, abacus, because that's what all we use. And it's interesting because in school they're taught that they have to memorize 12 times 4. Well, I don't want to have to memorize what 12 times 4 is. So what we do in Abacus is we times it. We do this and then we do that. So that's the beginning of what concept is that the beginning of? Audrey, are you still here, Audrey? Yeah. What is that? This is distributive property. When do you use distributive property in math? Other than, well, for me, I only use it in Abacus. I only use it in multiplication. I don't know if Audrey's there. Okay, so in Abacus we talk about the place value. So we do actually figure out how to do 3 place values, 1, 2, 3, right? And then what we do is we multiply. 4 times 1 is equal to 4, and then we do 4 times 2 is equal to 8. So how does that relate to here? Well, the interesting thing is if we made these double digit like this, right? 4 times 1 is equal to 0.4. We can do that. So what we do is we count the column. 1, 2, 3. 1, 2, 3. So I'm going to start here, but my first number is 0, and I add the 4 here. And then I add 8, because it's here. 2 times 4 is equal to 8. So 8's over here. So the kids don't have to memorize what 12 times 4 is. They can just do it on the abacus. But the thing is then they really understand their multiplication table. So, yeah. Oh, it's for factoring. So this is the beginning of factoring. Okay. Okay, great. Yeah, right? So, but, okay. Introducing factoring. Yeah. Okay, I'm going to add that to my repertoire. So even when we do big numbers, we do like 360 times 24, right? And it's the same concept. We still do distributive property. We still do, okay, we'll do this. We do it multiple times. We go 12, we 2 times 6, no, 2 times 3, 2 times 6, 2 times 0. And then we do 4 times 3, 4 times 6, and 4 times 0. We still do that. So how do we do it? 1, 2, 3, 4, 5. So we count the amount of columns and where we're going to place it, right? We're going to place it over here. 1, 2, 3, 4, 5. So we do 2 times 6, right? 2 times 3 is equal to 6. 6 is 0, 6, right? 2 times uh 2 times 6 is 12. So we add 1 and we add 2. And then 2 times 0 is 0, right? That's fine. So now we redo it. We've already done this. So now what we need to do is we need to find our place value again. 1, 2, 3, 4. So we're going to start at 4. 1, 2, 3, 4. So then we have 4 times 3 is equal to 12. So we add 1, we add 2. And then 4 times 6 is equal to 24. We have 4, we have 2. Okay, so here's our question. Is there enough to add the 2? No, there's not enough to add the 2. So what do? Can we add the 5? Yes. So what is the 5 frame? 5 frame of what is the 5 frame? Well, 2 plus 3 is equal to 5, right? So when we move this over to here, we need to plus the 5 minus the 3. And then plus 4. And then 4 times 0 is equal to 0. So my answer is 8,640. So, anybody have questions? So that's a little bit about distributive property and factoring. So that's what we are doing, and that's how it's related to Abacus. Yeah, it's crazy. It's crazy, like going down this path of trying to get Abacus to relate to American math. I don't know what other kind of math, like Western math. I don't know, like in Europe, what they do and so forth. So I'm just this. What my goal is to try to relate American math to Abacus. So if anybody have questions, let me know. But thank you, Audrey, for keeping track of all of the comments. I really do appreciate it. So, anybody have questions? Let's see. I'm just checking to see if there's any comments or questions. But I'm actually going to head out. This was going to be a quick thing because I wanted to just kind of come on board and just get my creativity up and going. And what we're doing is, oh, I have a class. That's why. Because I have a student I have a student. I have a class at 9:30, so it's going to take some time. So it's still morning for me. I'm in LA. But yeah, so that's the great thing about, and then it goes back to putting the factors, so yeah, multiplication factors into long-term memory. And so we do this often, and then the greatest thing about it, when we talk about Abacus and we talk about the Abacus method, we don't just learn the multiplication way, we actually learn the division as well, because what we do is we reverse it. What times 24, what times 6 is equal to 24? This is a common vernacular. This is a common concept for us in Abacus. So I never learned how to use the Abacus. Oh, hi, Hunter. Let me show you. I don't know if you want to learn. Anyways, so Hunter, just so you know, this is the beam and this beam is what's counted, right? And so what we do is all the beads on the bottom bead has a value of 1. So we do 1, 2, 3, 4. And then if you notice, there's no more beads at the bottom. So how do we do 5? Well, every bead on the top will be a value of 5. This is the top and this is the bead. So this is 5. So this is 5, this is 5, this is 5, this is 5, this is 5. But the difference is it's the place value. So this is 5, but this is 50, but this is 500. So this would be 5,000. Sorry, I'm doing this on the fly. So continuing on, if we go back to 5, right, we do 6 and then 7, right? 5, 6, 7, because this is the value of 1 and this is the value of 5. So 5, 6, 7, and then this is 8 and that's 9. So then we actually do 10. How do I know that this is 10? Well, this is 0 and this is 1. This would be the place value of ones, tens, hundreds, thousands, 10,000. So then there's always the other side of the decimal, right? The other side of the decimal, if my imaginary decimal is right here, right between these two columns, this would be the tenths, right? And this would be the hundredths. So this would be, if this was money, it'd be $2.01, right? $2.05, $2.25, right? This is 20. So this is the decimals, and then this is the integers. So thank you so much for the gifts. Wow. Oh my God, 3,000 views. This is crazy. Let me know if you have any more questions. But I do got to get ready for class. So going on to just understanding and recognizing what the beads are. So the first steps is to recognize and understand what they call a bead recognition. Just like they do number recognition, and then they do letter recognition. While in Abacus we also do bead recognition. Excuse my poor handwriting. Recognition. Yeah. So that was the one thing. So we do bead recognition because we're actually using the abacus as a manipulative. This is what we call a soroban. This is a soroban. This is a Japanese version of an abacus. I have a Chinese version of an abacus. It's a little bit more. It's a little redundant because Chinese people are redundant. I'm Chinese, so I can name it. But anyways, so if we're looking at it in the Chinese abacus and the Japanese abacus, right? So Japanese, they all do is they make it more efficient. Let me show you how redundant the Chinese one is. So let me do that. Yeah. So we count. Notice this one doesn't have like a place value, so we're going to start here just to keep things simple. And I'm going to start here just to keep it simple, right? So we're going to do 1, 1, 2, 2, 3, 3, 4, 4. Now, in the Chinese abacus, we could do 5. On the Japanese abacus, this is only 5 and 5 only. This is the only way to do 5, right? But on the Chinese abacus, that's another way to do 5. And I'm like, that's a little complicated because I'm going to have to remember 2 ways to do 5. It's either 5 or 5. Now, we can continue. When we continue on, we do 6. See, that's the thing. You could do 5 and then that's it. That's great. But the problem is when you want to count 6, we got to do another movement, right? So we have to make sure we have to add this. We have to have the 5. So then there's 6. That's 6, and then 7, 7, 8, 8, 9, 9, and then this is where it gets funky. So we have 10, right? On the Japanese abacus, it's 10. Chinese abacus, we do 9 and then 10, or 10, or 10. So there's 3 ways to do 10, and I'm like, wow, that's like, if I'm just learning how to do the abacus, or even like later down, like I know how to do abacus, I'm going to have to remember. That's too many things to remember. That's too many things to remember, right? So it's like one of those things. So the blue values can be read. Yes, exactly. So the blue values, but it all depends on where the dot is, right? So it all depends on where the dot is. I chose to have my ones place over here. And so if my ones place is over here, this will be 5, this will be 50, and then this will be 500. This will be 555, right? And so this is a nice marker because this tells me this is my thousands. I could start my ones on this side. This, however, is a more playful abacus. When you get to the serious abacus, is all one color. But it's still the same concept, and it just depends on where you want to start. You can start your ones here, 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 or here. If you notice, there's these little dots. These dots are to help you figure out, where your place value is, because then you won't lose track where you are. Because sometimes we'll be like, oh, there's this number, and then like if I did like this number, 210, right? And I walk away and I come back, I'm like, oh no, where did I start? The good thing is I know I started at, this is the 200 because this dot is my ones, right? If we didn't have any place value, that's what I did. One time I was teaching on this just to show, and I walked away and I came back and I'm like, oh, I don't remember where I put my place value is. So that's why it's nice that these are all labeled. So going back, it's the blue beads. It's really the position of the beads. The top beads all has the value of 5. The top beads of the bead. So we can, when we use this is a student's abacus. When we use a student's abacus, they all just move very freely because usually they're used for abacus competitions. So yes, that's exactly what it is, Hunter. And then we have the place value. So then this is the tenths, right? If this is the ones, then this is the tenths, the hundredths, and so forth. So if anybody have any questions, thanks for watching, everybody. Thank you, Audrey, for helping so much. So that's what the abacus is. But yeah, I mean, I like the colorful one because I think the kids like it colorful, but now they're like, my one student's like, I want to graduate to like the boring one. And I'm like, I don't want to go boring. I do like the colors because it makes it pretty and it makes it fun. It's a little boring. And then there's a bigger one. I mean, it gets crazy. So this one is a lot longer, if you notice. This is the what do they call it? Standard abacus competition. And there's a buttload of numbers here. I think it's 27. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 23 columns. That's a 23 column number. So here, if you notice, these also have the dots, right? So it just depends on where you want to go. If it's big like this, I usually start right in the middle. It's just easier because you could do the whole numbers, right? The big numbers, or you could do the decimal numbers, right? You have your thing. So do you use the larger abacus when working with?
Yeah, you can, or you can use a small one. You could use a small one, but then you would have to really struggle, right? Because you could start from here: ones, tens, hundreds, thousands, 10,000, 10,000, 100,000, 1,000,000, right? We could, if you're really pushing it, or you could go and you can quote unquote graduate to the bigger abacus. So that's the difference. But there is also a big one, like there's a teacher's abacus. I use a teacher's abacus, and this is my teacher's abacus. It's a lot bigger so then the kids can see, across the room. But it's the same concept. It's the same concept. The big thing is just understanding how to move the beads. When you move the beads, so then notice like the Chinese abacus, it's a little clunky. The people actually use it. Oh yeah. Abacus is everywhere. You know what? Let me see if I can find my little thing. I started collecting pictures where we use abacus, and I'm like, that's crazy. So the funny thing was, like my kids, because my kids, I taught my kids. I have 3 boys, and I taught my kids how to do abacus, and they're like, oh look, there's this abacus over here, and I'm like, what? And it was crazy. So here, if you look, I want to present. So if you look, I actually found, it's actually in Willy Wonka. Have you ever seen the movie? There's one in Willy Wonka. Who is it? It's the character. His name is Abacus Crunch. Who would have thought? Abacus Crunch. See, there's an abacus right there. This is a different abacus. This abacus is not this. That's a Russian abacus. That's a different abacus. But his name is Abacus Crunch. And who would have thought? Right? It's so funny. So then, you know what? Penguins of Madagascar. I was looking at Penguins of Madagascar, and I was just kind of like, oh, this is a fun movie, whatever, whatever. And then they start talking, and guess who this one has? He's got the Chinese abacus, but he's holding it the wrong way. He's holding it this way. So, Penguins of Madagascar, thank you so much for all of the gifts. Thank you, Audrey, for helping. So, yeah. So they're in movies, but nobody really notices it because it's just kind of like whatever. Like it's actually quite amazing. So here's another thing. It's in a book. This is an older book, right? But it is in a chapter book. And what this one did is they actually made an abacus out of acorns. So that, because what happened was is this child, she's blind, and they wanted her to learn. But because she was blind, she couldn't go to regular school. So they actually made an abacus so she can learn how to count. Yeah, so here it says, we'll make an abacus with acorns. This way the people counted. This is the way people counted 2,000 years ago. This is the first needle that will stand on the ones. Then the second one will, so then this is the first needle, right? So this is the ones, right? This is the ones. And then it says the second column, second needle is the tens. And then the third column is the third needle will be the hundreds. So they were using an abacus out of acorns. So this was out of a book. And I was like, that's crazy. Oh, this one. So my kid was playing this game called Empires and Puzzles. I can't remember the. And if you notice, there's a person, his special skill is pulverizing abacus. And I'm like, what? I was like, how is that even? But there's characters and there's people that know what an abacus is. This one is not a proper abacus. Because or he's holding it wrong, right? Because you don't use it this way. It could be just a Russian abacus that just goes across. But now I'm just analyzing it. I'm overthinking it. But anyways, going back, there's a game, a mobile game, and his weapon is a pulverizing abacus. Maybe I should call mine pulverizing abacus. I don't know. So, anyways, then this one, and this game's a little addicting. It's the Match Factory. I don't know if anybody plays Match Factory, but I started playing this stupid game, and it's really kind of addicting. So this game is, yeah. The abacus has been around for centuries. Oh my God. There's one lady, I was talking about abacus, this one lady. Yeah, it was a lady. She went by the name of whatever. So she was like, what is this new abacus? I don't want to have to learn something. I don't want to have to learn this new abacus. I'm like thinking. I was thinking it. I didn't say it. I was being nice. And I was like thinking, lady, this abacus, this abacus math is not new abacus. It's old abacus. Anyways, so there was a little redundant. Anyways, so there's this game that I saw, and I was playing this game, and it's really kind of crazy. The Match Factory is talking about match 3 items to get it off the board. So we get this bunch of board, right? And I don't know if you notice that there's a bunch of abacus. Can you find the abacus that's on there? Yeah. Crazy, right? There's one here, and then there's one here. And then there's a Rubik's Cube. So if I do it again, where do you see the abacus? I see one here, and I see one here. And then, again. So if you match 3, then, but yeah, the game itself has an abacus. And I'm like, that's funny. Abacus is everywhere. Oh my gosh. And that's it. Yeah, that's all I got. So, going back to here. Okay, anybody have questions? I just find it fascinating. Like, I really do like abacus. I think it's the greatest thing next to sliced bread. My kids did it. They have a really strong sense of number sense, but you know what I've noticed is they're actually more confident in who they are, because when they're given questions and they have the right answer, that just builds their confidence. So it kind of like builds on top of each other, right? So because they know how to use the abacus, they know what the answers are. If they know what the answers are, they're willing to go outside of their comfort zone and, answer questions when it's like reading or science or whatever that they have. Right? Oh, show the books again. Sorry. Yes, here's my books. Thank you so much for the reminder. So here's my books. And so, all right. So this is the beginning one that I have. And I have it where starting off the learning how to do the understanding how to read the abacus. So a lot of it, the front part of the book is about bead recognition. Right? And understanding the relationship of the numbers. And that's what it is. It's just the relationship of numbers and how the numbers are related to the abacus. Right? That's all I'm doing. So here, and I noticed the book is a little heavy, right? It's a little thick. But it will go through, at least it takes one of my students, took him a year to go through this. Another student that I had, he's really got some really strong number sense. It took him maybe, I don't know, a few months to go through it, because all it is just relating to like the items to the abacus. And so what I'm trying to do is I'm trying to show the bead recognition to this. Is there a 5 when you do? Oh yeah. So going back to this, yes. So when we do 5, I'm sorry, I didn't. So there's a 5 in each column. So if I do 5 and then this is 50, so there's 60, right? Because this is 60 and then this is 60 and then this is 70. So this is 70, right? No, so this is 7 and this is 70 and then this is 777, right? So wherever we are, we're always going to have that same number. So you're always going to have a 9, right? You're not going to have 10 here, right? You're not going to have 10 beads here. You're going to have 9 beads. So that's the cool thing about Abacus is it really does help with subitizing. And what is subitizing? Subitizing is like understanding what the numbers are and being able to recognize what the numbers are. So what does that relate to? That relates to a die. In school, they're taught how to read a die. So here's my die. This is 1. This is 4. So on the abacus, this is 4. But notice there's only 6, right? And they do 6 like this. This is 6. So when we do subitizing, they only go up to 6. But on abacus, we go up to 9. So if I do that, we know that that's 9. If I do this, if I quickly look at it, I have to look at it and be like, oh, that's 8. How do I know? Because there's 1 bead here, right? 5, 6, 7, 8. So then when you count it and you subitize, when you look at it, that's 7. How do I know? 5, 6, 7. Well, this is 70 because this is the 0 column, right? So the tens and the ones, and then the hundreds, right? So this is 700. 700. We know that these are zeros because none of the beads are touching. The beads are not counted. So when the beads are not touching the beam, it's not counted. So we know that these columns are zeros. So yeah. So was there any other questions? Oh yeah. Yeah, these are not your traditional abacus workbooks. Like I try to make it more interactive and make it more entertaining, engaging. So I have activities where they can do things, and then I have like some puzzle pieces. There's a puzzle that I already created, and then with the puzzle board, and then I try to show what the beads are, and I really like this. The more I look at it, the more I really like it. Like this is my first book that I created. Obviously, I've gotten better to like other books. So I have it where after you do the first bead, after you understand how to add simple adding, then there's the 5 frame and then there's the 10 frame. And so I got to, do the others. Marinas. Hi, Marinas. Okay. I'm going to head out. I've been on for a while and my live will end in 4 minutes. So there's my puzzle piece. All right. Oh, verify. I'm verifying. Verify. There we go. So, anybody have any questions? Mimi. You're here too? Mimi, how's the weather in New York? Where's Marinas? How's the weather in New York? Is she still here? Hi, Marinas. So, funny to catch you here. If anybody has any questions, it'd be great to answer any question about the abacus. So, thank you, Hunter, for asking all these questions because they're fantastic. Hopefully that made a lot of sense. Let me know if it doesn't make any sense, because I am so happy to explain and to talk about abacus and trying to relate to it to American. Really, it's about the American math system. So that's my goal, was to try to relate to it and make it kind of exciting. So this, tic-tac-toe. One of my students really likes tic-tac-toe. And then there was a maze. So we did a maze. And we have it where, you start from here, you answer the questions and you try to figure out what the answers are, right? And you follow this maze. And it was really cool. He made a comment, and I'm going to update it. He made a comment he didn't like how, he was like, why do worms go to apples? And I'm like, well, that's what I know. So that's what I did. So, but he didn't like this. he had the butterfly catcher to the butterfly. He's like, why are you catching the butterflies? They should be free. And then he was like, well, maybe you should, instead of saying a net, you should put in a flower. And I'm like, oh, that's brilliant. That is brilliant. So I was going to update this to make it into a flower. So the butterfly goes to the flower. So that's what I like the most. Wow, 29 people. That's crazy. Good morning, everybody. Good afternoon, everybody. Good evening. I don't know where everybody is, but I know where 3 of you are. So, anyways, I have the color by number, and and I have word problems in this one. I gotta add word problems to my other ones, and then this was just talking about the 5 frame. So there's instructions on how to do it. Right? So if you don't want to take my class, I have an online class, but if you don't want to take my class, I do have instructions, so it can be not creepy at all. So can you move the pieces on the abacus so I can guess the number? Oh yeah, for sure. So when I have my abacus, I'm going to tell you, this is my ones. So if I did this, right? If I did that, can you see that? What number do you think that is? I'm going to wait. That's a great idea. Okay, anybody get this number? Mimi, do you know this number? Marinette? Come on, you guys been watching me for a while. Audrey? Okay, 5,289. Fantastic. That is correct. Well done. So, the one thing about the abacus, right? One more thing. The one thing about the abacus is when you're holding the abacus, you should hold it with your left hand. Why? Because it's easy to move. And so there was one time where my brother's also an abacus teacher, and if the kids are not holding the abacus, he'll walk by and he'll do this, and it messes up all of their numbers. And so the idea is hold the abacus with your left hand and do the calculations with your right hand. The reason why is, oh, good, Marinette. Well done. Yeah. The reason why is because they talk about the calculations happens to your left brain. So it's left brain with the calculations, right brain does the arts and stuff. So here's another, there. What number is that? There. There's a lot of, okay, what number is that? So if this is my, see? If this is my ones place, right? My ones place, this is the tens, this is the hundreds, and then my decimal will be right here. What number would this be? Not 6, 7. So 626.20, yes, 0.27, 0.67. Fantastic. Yep. But notice that I just moved it a little bit and all my beads fell. So that's why we have a bigger abacus, because the bigger abacus actually doesn't fall. Right. So if I have my big abacus and I hold it like this, my big abacus and I hold it like this, I could do that and it won't fall, because it's meant to be like go across the classroom. And then the other thing is my marker is movable, because depending on what we're teaching, right? I can say, well, if I'm talking about decimals, I can move it to here. If I'm talking about, big numbers, I can move it to the other side. So well done. So here's another. So, okay, so if I did, I don't know if you can see that. Oh, no, I don't want to do that. You can't see the big number. The bigger the number, the better, right? So, if I have this, oh, no, let me see. Let's see. So here's my bigger number. And then, I don't know if we can, there's only so many numbers, right? That's the thing, right? So if this is my 0, these are my 1s. So this is my 1s. What number would this be? And then we'll do that. Can you see that? So if this is my 1s, see, it's harder to see. See, it's harder to see. Okay, so these are my 1s. So I have this, that, and then that. Okay, so this, it goes to here and then goes to here. So what number do you think that is? Okay, there's more though. 8, 7, 2, 1, point, right? Point, 0. And then what number is that? Yeah. So then it's like, so it's 0.0807. Yeah. So don't forget, when you mark this as a 1s, these would be the decimals. So, yeah. But I don't use this abacus because it's a little big. But right now the questions are not so big that I don't need to use this. So, but anyways, I use the smaller abacus because it's easier for the kids to see. And right now my students are, I think my oldest student is about 6 or 7, and they're just going through it right now. And so we have it where they go through understanding, how to add and subtract. So they're doing adding, subtracting, and then they have to do the 5 frame. And then after they do the 5 frame, they're going to learn how to do the 10 frame. And then after they learn how to do the 10 frame, then they learn how to mix the 10 frame. It's so crazy. I love this. What time is your session? Oh, you know what? My session is at 9:30, so I'm going to head out. Thank you so much for the reminder. I'm going to head out. Thank you, everybody, for joining me. I'm going to, if you're looking for these books, I have these books available on Amazon. They're available on Amazon. I can't figure out how to do it on, on the TikTok shop. But yeah, these are my books, and I'm creating more books. I'm on book 7 now, so I have like 6 books so far. And I have one that's just a coloring book. Oh, I have a coloring book. If anybody's interested in a coloring book, I have a coloring book. And it's just a simple coloring book, and it's to create, and it's to build your creativity. Let's see. So, okay, one last thing. So here's and this is when I started, and I started to just be creative. And so it was meant to just, provide creativity, but also learn how to read and, how to read the abacus. That's all it is, reading the abacus. And so it goes all the way to 100. I haven't done it yet, if you noticed. I'm still in the process of. So that's 100. 0, 0, 1, 100. So, all right. And then I do like all the way to 29, 30, and then the 10s. So yeah. Anybody interested in a coloring book? Simple, right? I like it. Obviously, because, so yeah. Anyways, thank you, everybody, for joining me. But I do have to head out. I have a class, and I got to get ready for my class, and I have to start printing out, and we're going to be talking about the +10 formula. So thank you again, everybody. I'm going to sign off. Have a good day. Bye. Thank you, Audrey, for all your help.